Yeah, good morning, everyone. Is my voice audible?
Yes, yes,
Okay,
you're
let me share my screen. Yeah, good day, everyone. I will build on the existing protocol and continue with where Professor stopped. So today, I'm basically going to handle more of tutorial where we want to look at some options of platforms, Mininet, NS3, Network X. I decided to talk about Network X, looking at one of the questions also in the chat. Network X also is not a very robust platform, but it's a platform for those who want to work in simulation and network simulation environment and will have a limited resources. So you could do little form of research, even with your little financial resources. As you know, most of these projects, sometimes even not having access to financial resources can also limit you to extent of what you can do. So today I'm going to show various options so that we can leverage on the little resources we have if we have any problem of financial resources. Today we are looking at network modeling using Mininet and others. So the first question is to first of all put in context that Mininet is a network emulator, and we've been able to establish the difference between emulator and simulator. The major difference between emulators and simulators has to do with the ability to imitate, the ability to replicate system behavior, the ability to replicate the hardware interface interaction. So that is what established the difference between what you refer to as an emulator or what you refer to as simulator. This is not new. We've seen this in the previous presentation by Prof. I also added the paper from our lab, the link to our paper where you can also see a practical usage of this environment. So here you could see the difference between in a simulator, you are trying to represent the system, but in the emulator, you are trying to replicate the behavior. You are trying to make sure that what you have in the simulation can be to some degree a one-to-one interaction between what you have in the emulator. And in this particular case, this is a particular case of a Mininet OpenDSS integration using the Python wrapper. To to do that, the first thing we need to learn is where do we get the Mininet? The link you are having here, the mininet.org download, is where you can download the Mininet, and also in that website, it is also advisable that we work with Python 3 to avoid the problem of backward integration. Also, if you want more video about the PY-DSS interface, you can also watch the GitHub video by Paulo Radas. Paulo Radas is one of the working committee members that helped in the integration of OpenDSS and Mininet. So most of the work you will see online are by Paulo Radas. Now, to do that, in the Python, there are different ways, but in my demonstration, I am going to use Google Colab because it's easier for me to use it for the purpose of teaching. I'm also aware that people can do their work in different platforms, but in this tutorial, I'm going to just be demonstrating only with the assumption of working in the Google Colab environment. And these are the first thing is to install the DSS interface, and then when you install the DSS interface, then you can import. And then if you import, now depends on the subsequent things you want to do. The subsequent things you want to do determines what additional lines of Python codes you are going to have. But the basic one is, first of all, to do the piping install of the OpenDSS Direct, and then to import the operating system, and then the subsequent lines of code depends on what you want to do and the environment in which you are working. I'm going to leave this PowerPoint and go to Google Colab in a very short while. So this is an example of how it is in my Google Colab. When I install the PYDSS interface, and then I import the PYDSS interface in the Google Colab, and then you run. If you run it, it will tell you that it is successfully installed. So if it is successfully installed, then you can move to the next stage of whatever you want to do. Because one thing I also want to establish is that before you do anything on Mininet or OpenDSS or whatever, you have to establish what do you want to do. So that is very important as well. So this is a recap. So if you want to load a simple OpenDSS, then you have to create the DSS instance. So when you create the DSS instance, then you define the OpenDSS model, then you run your command. If you run your command, then in running your command, one of the things you can run in your command is something as simple as just computing the power flow, or trying to know the voltage in the grid, that the simple grid that you have trying to establish, which I'm going to show immediately in the few moments from now. But one thing I like about OpenDSS Direct is that it is designed for cross-platform, which means it does not have the problem of depending on Windows or any specific OS. So some people are tied to working only in Linux environment, but with OpenDSS Direct, you could work in Windows environment, we could work in Linux environment, you could work in, but we know that most of the successful integrators they always argue that Linux is your best platform, which I don't want to dispute that. But I also have I know that from my experience as an instructor, sometimes when you want to teach in the class, or you want to demonstrate certain things, you want to see how is it possible for me to work in ordinary Windows environment due to the popularity of Windows. So everybody's trying to see, even though this can work in Linux, can I do it also in Windows? Can I do it in any platform, so I don't have to be tied to a particular environment? So that's why I embrace the OpenDSS Direct, since it could allow me to work whether in Linux or not in Linux. And don't also forget that some people may not have experience on how to use Linux, and so they want to do something, they still want to do it within the Python, they want to do it within the Windows environment. So to do that, the OpenDSS Direct allow you to have the OpenDSS COM, and then with that you can do your work. So what I want to show, the simple demo I want to show is I want to define a simple circuit made up of voltage source, a line, and a load. I want to solve a simple power flow, and I want to print the voltage at bus 2 of the total power. Then I want to visualize. That's what I want to do in the Google Colab, where I'm going to go to now. So let me leave this environment and then show the simple line of code in the Google Colab environment. Yeah. So if you look at it, if you look at the example here, I started, the first thing I started was I started by cloning I started by cloning the GitHub. The reason I'm trying to do is I don't want to leave my Colab, so I want to force everything to happen in my Colab. So the first thing is the line of code to clone the Mininet from the GitHub. So when I clone it, then I successfully have my Mininet environment. Then the next thing I did was to install the DSS interface. So when I install the DSS interface, running this line of code, and it tells me it is successfully installed. Then, even though this is not important, but I try to check the Python version this my Colab is working with. I already know it's Python 3, but I just want to still emphasize that, okay, the version of the Python I'm using is Python 3. And I also want to advise, if you are working in Colab environment like myself, there's no point going backward, because when you try to go backwards, you have a lot of error codes, and it's frustrating trying to debug and the rest of them. So it's better to work in the version 3. And there are so many community support for Mininet, OpenDSS, and Python, OpenDSS, Direct. There are so many supports online. In fact, in the Colab, the recent Colab, if you operate Colab with your Google account, Colab now comes even with the Gemini support. So with Gemini support, even sometimes you are running your code and your code is not working, the Gemini support also assists you in helping to debug. And then it allows you to debug and correct yourself. The only caution here is that when you are working with Gemini support, also be aware that it is an AI, and it can also have hallucination. So sometimes you are it's trying to support you, but in trying to support you, it's also misleading you by giving you some code that is working, but it's not working according to what you have already designed. So you have to be careful about that. But Gemini is very useful and very helpful when you are working on Google Colab. So in doing that, then the next one is to we'll install we try to get all the archive and the COM. We try to link to the Ubuntu, because now, remember, I said I don't want to work in Linux. So, but I still want to behave as if I'm working in Linux. So I try to link myself to the Ubuntu environment to make it look like I am in that environment, and that was successfully done. Then the next one is to now install the OpenDSS Direct. So after installing the OpenDSS Direct, then I now run the simple code, the simple command of the boss that I just want to try using this code. Now, there's a comment here. It says that I must create my circuit, because here I have only created the integration. But after creating the integration, I have not done any grid or any voltage integration or any form of thing that will lead me to doing any calculation. What I have done here was just to I just made the OpenDSS and the Mininet to be able to see each other. And that is all. I didn't do anything. That's why the last line of my code says, you must create a new circuit object first, and then you can now do whatever you want to do. And to do that, I also will share the next Colab platform that shows the simple code that I did in that one. So most of my class will be I'll be doing more of sharing and sharing, just to make sure we are on the same we understand ourselves. So let's see a simple one. This one, yeah, let's see. So here, the early codes are still the same, so I don't want to repeat this one. These are the same. So here, to run the simple one, the first thing I did was to import. It's already installed, so I just import and make it a DSS. Then I put my DSS command. So here is what, remember Professor was saying something. He said, you have to decide what you want to do. So for the purpose of teaching, I just brought this one. So the first thing you have to know what you want to simulate before you simulate. So in this case, I just brought a simple two-bus system with a power factor of 0.5. I put the value of the bus, the load of the grid, and the rest of them. This may not be the realistic grid. This may just be a simple grid that is not even realistic. But this is just to show you So if you know your actual values, then you can replace the actual values with these lines of code, which I will also make available to the facilitators. I've run this code, I've tested them, and they are all working. So to make my class very faster. So what I'm saying is that here, in this establishing this command, you have to decide what you are going to, the values that you're going to use. How many, your length, your units, your kilowatts and your power factors. In this case, I use 0.5. I use this 0.5 because when my former colleague was teaching us the MATLAB OpenDSS integration, he used the same 0.5. So I try to replicate what he did with the MATLAB OpenDSS and see if we can get similar results. And then when you do that, then you run the code, the result. You have the result. The result is here. This is your output result for the grid based on that particular value that I imputed. And to make it more visualizable, I'm always a fan of print. So just to make it more visualizable, we print the values of the bus voltage in PU, and we also print the total power in kilowatts and kVAR, which is this are the various output. So this is a simple case where you can use the Google Colab to establish a connection between your OpenDSS and your Mininet, and also to establish the simple grid features that you want to simulate. Then you run the simulation, and then you see the outcome. So I go back to my slide. So like I said, the interface, the essence of the interface is you want an emulator and a simulator to see each other in order for you to carry out an experimentation on whatever your target goal. In this case, our target goal is any grid, any smart grid, or any grid for that matter. So that is important. The next one I want to show, apart from the Mininet and the OpenDSS, which requires dependencies and the Python environment to make it run. There's another one also known as the NS3. So in NS3 is also possible in Colab if you can connect it using the Docker container. And to connect it using Docker container, the line is very simple, just this simple 2 lines of code. And when you do that, then you can now work in there with NS3 using the Docker container. Then sometimes also, if the NS3 also is not it's too complicated for you, you also have a simple network platform known as NetworkX. So NetworkX is a very simple platform. Why did I say simple? It's simple because it's more like you are using a graph to visualize the whatever you are trying to do. In this case, I use my graph to visualize a simple diagram of a connection between nodes and bringing lines and nodes. So in that case, you now establish them as if you are trying to draw a grid. The only disadvantage or limitation here is that you cannot use it to interface an emulator. The way you are able to connect your Mininet and OpenDSS, you cannot use NetworkX to connect with OpenDSS, because NetworkX is just like what I will call a demonstration tool, a networking demonstration tool that allows you to still do a network simulation, but network visualization, not network simulation, whereby you have it. So this is an example of just a three nodes that can be used to connect a network graph. And if you do this, if you run this code, then you see something like this. So this simple code here, whereby you import your network X and then you put the matplotlib. Of course, if you are comfortable with Python, you know that each time you are trying to use your matplotlib, you are only trying to do a visualization. You are trying to draw something. So, and what are you trying to draw? You are trying to draw a simple network with 4 nodes using the nx.graph, and then you put all the the distance of the graph, so that you are trying to establish the distance of the graph, and then you plot the graph. Here, I just try to kind of do some aesthetics by trying to put some color and the rest of them. And then I show. So in showing that, you just have something like this. This may not be too important right now, but it's going to be useful for me when I'm going to show you how to use it with another type of tool again. And so in summary, what we are saying here is that you install your Mininet, you install your OpenDSS, and with the PyDSS interface, you can make the Mininet and the OpenDSS to see each other. And once that is done, then with your Mininet to Python dependencies properly done, you are good to go to test your OpenDSS platform Python interface simulation according to your desired interest, according to what you want to do. I will also drop some GitHub links to assist those that may want to do some, if you want to do the practice on your own. I will drop some of the Python links in the comment section. The GitHub links to some of the code in the Python section. So the point I'm trying to make here is that we are aware that the best way to run Mininet is a Linux environment, but that is becoming not completely the reality now. It could be anywhere. Mininet is still working best in the local machine in the Ubuntu, but you can see how I was able to bring in the Ubuntu into my Google Colab and still behave as if I'm working in the cloud VM. And then using the Docker-based solution, like I was able to still work with my environment, even though I am working in my Python Google Colab environment. However, those who are very good in MATLAB, they can run their OpenDSS MATLAB.com interface, just like what my colleague Niloy demonstrated during his own presentation time. So this is how the Ubuntu configurations, if you are going to use NS3 on Ubuntu machine, this is the line of code, which I also going to drop everything in the comment section for those that want to make their practice. And then from the Mininet installation guide website, you could see what I was trying to say. They have different options you can use Mininet, but they recommended option 1, which is what I'm trying to also say. So when you go to this website to download the Mininet, you will see that they recommended that you should follow the first option. Why? The first option is very easy. It allows you to install the VM installation and also allow you to work with Python 3 instead of going backward integration. The other options are there, but like I said, the other options are with your experience. You could embrace the other options, but as a beginner and as a initial user, I will advise that you stay with option 1. I have stayed with option 1 and it's easier for me. And for me, if something is working and it's easy for me, there's no need looking for a complicated way of doing whatever is working for me. So this is what I was trying to say. You have to go for Python 3 so that you don't have to have a problem with going backward. Because if you run Python 3 and then you have problem of being able to go backward. Now, another simulation I want to do also is the PyPSA. The PyPSA is also a Python for power flow system analysis. It's also some lines of code that allow you to install the required package, define a grid in a PyC environment, perform power flow calculation, then visualize the result using your Google Colab. So I will Can you see my screen?
Yeah. Yes.
Okay, thank you. So let me show you an example on how I can combine the network X and the PYPSA. So the first thing I did here, I first of all, I installed the network X matplotlib. Remember I told you each time you hear matplotlib, you just remember that I'm trying to draw something. I'm trying to make a plot. I'm trying to draw something as if I'm in the MATLAB environment. So I installed the network X matplotlib, and if it is successfully installed, and you could see it telling me already satisfied, because this section of the code I'm showing you, I have run it before. I'm just running it again because of this class. So that's why it tells me that it's already satisfied. Then in doing that, the next thing I did was to import my network X and then give it a extension name NX. So I don't need to write network X anymore. I import the matplotlib and I gave it a name PLT. So I don't need to, I can continue with the PLT as a name in my subsequent lines of code. Then I define the smart grid network using those very small buses and transmission lines. I draw the grid using the NS graph, which is the network X line of code for this. So I define my buses. Like I said, I'm trying to use something very simple. It may not be the realistic grid, but it is sufficient for my discussion. Then I define the power transmission line using this one. I put the edges. I draw the network, which will show something like this. So I am trying to show a smart grid network 1, 2, 3 that have this power between them. Now, let's now do the power flow system analysis. To do that, all you need to do is just to install the dependencies. So we do the pip install PYPSA. So once you do the pip install PYPSA and you run and successfully run, then you are ready to run your power system flow calculation, which in this case, I try to establish the parameters of my equation, and then I ask it to run. When it runs successfully, this is the output. So you see, there is nothing so in the Python environment, there is nothing so strange. It's just for you to know what you want, and then once you know what you want, the 1 or 2 lines of code does the magic for you. So this gives me for the bus 1, the bus 2, and the bus 3. The bus voltages and the power flow on transmission lines also comes in this way. Then I did something. Then the next thing I did was I said, okay, in this diagram, that was just ordinary node, right? I was now like, okay, can we modify the code to maybe add a generator, to additional generator, or a battery as an integrated renewable integrated source, additional source of power into any of the nodes of this grid by adding additional battery. So the original lines of code, when modified, so here, when modified, I added the battery storage system at bus 2. I just added the battery storage system at bus 2. So it depends on what you want to do. Do you want to add the solar? Do you want to add battery? Do you just want to play around different scenarios in the grid? You want to add something to the grid? You want to add a generator? You want to add a battery? You want to remove a battery? You want to cause a failure? Maybe you want to do a resiliency analysis. So you want to say, okay, can I put the battery, do the power flow? Can I remove the battery, do the power flow again? So let me see the effect. When I put the battery, what was the power flow? When I remove the battery, what was the power flow? Something like that. So that was what I'm trying to play around here. And also for those who are also instructors, this is also another way we could do a simple demonstration in the classroom to explain the resiliency issues and the integration issues to students in the classroom. And when that is done, we have this output. So remember before we had the bus result, we had the power flow line result. Now we also have the battery result. And then can I draw that? Can I now to draw that and recognize that battery that I've added? I repeated my network X again. And to repeat my network X, I have to redraw using my network X, and it gives me something like this. So here I now have the battery in my bus number 2. I now have the battery in my bus number 2. Okay. Yeah, so the next line of code, I will leave this next line of code for when I would tomorrow when I will teach you physics informed neural network. So I don't want to go into this place because this one I have to explain what is physics in neural network for you to understand this next line of code. So that is just the importance of another importance of the power flow system analysis, the PSA. So this is a repeat of what I've already explained in the collab. Because I was trying to make sure that in case I have a disappointment of my collab not running, so I just screenshot most of them and put it in the slides to avoid disappointment during presentation. So this is a repeat of what I've already explained. The step 1, the step 2 and 3, the step 2 and 3 of importing the PYC and then getting the power flow result, and then the result of the various bus and the power flow on transmission lines. So whereby the result is given in PU. So what are the steps again for the purpose of re-emphasis? 1, install and set up your PYPSA in Google Colab. 2, we modify the grid by just adding a battery. You could add anything you want to add, but then we simulate the power flow with the battery and then we visualize the results, which is this one. So this I've already explained this one. I said why. I said the requirement already satisfied, because if you already installed a dependency and you run a dependency again, the collab simply reminds you that what you are trying to install is already satisfied, already is existing. And this was the section of my code that was modified in the original code to bring in the battery element into that grid for energy balancing, kind of including a battery storage for energy balancing. It all depends on what you are trying to do, but this is just demonstration purpose. And this is the output result, which I've already explained. And then we try to visualize using the network X. And we got this that has the battery element in bus 2. It could also be anything. It could also be that you also want to create a down. You want to make the battery to be down and check the effects, or you want to make bus 2 to be non-functional and check the effects and all that. A very typical example of a paper you can read in detail from our lab is this particular paper. This paper is very useful. Cyber anomaly aware distributed voltage control with active power containment and DER. In this paper, you will also see the connection between the OpenDSS and the MiniNet, which was used to generate to simulate this particular paper. It was a very useful paper, and I encourage us to read it from the lab. The next thing I will also drop, some lines of code that will also help everyone to do some practice. I will draw some GitHub codes for for this one. So the first one I drop is for general teaching on MiniNet. Then I will also drop another one for demonstrating hijacking attack. So because the idea is that most of these things, for you to really understand and for you to really appreciate, you need to appreciate by doing. You need to appreciate by doing. And the good thing is that they are very straightforward. Then I'm also going to drop the code for the release, the Mininet release notes. And the last one I want to drop is I want to drop the, this one. I want to drop the selected smart grid network project using NS3, with their codes and their demo information. Yeah, so at this stage, I will give room for question and answers. Yeah, somebody says screen is not changing. Yes, my screen is not changing. I am aware. I am aware my screen is not changing because I want to attend to discussions and questions. Yeah. So this class is tutorial class. So I'm not really. It's tomorrow I will have a lecture. So tomorrow I will have a lecture. I will have a lot of things to discuss in lecture. But tutorial, I believe tutorial is more about doing and showing, and then we discuss with each other on practicality of something, not theoretical discussion.
Okay. Hey, Dr. Kasmas, I have just a general question.
Yes, sir.
As you were getting us insights about the Google Colab, for some projects, suppose we have a real hardware, suppose PMU. Can we take data from PMU into the Colab for different studies?
Yes. Yes. So if you want to take data to Colab, the best option is to, for me, okay, let me just answer the way I do my work. So when you have your data and you want to link it to the Colab, I will advise that you save your data and then you mount it in the Colab. You save your data, then you mount in the Colab. So when you mount in the Colab, you can now copy the pathway from the pathway of the Colab. You can copy the pathway and then put it in your lines of code where you are working. Let me see if I have any old simulation that have something similar to that. Let me see whether I have something similar. So I want to check any of my former Colab simulations. I have so many files in my Colab, so I can always check new notebook drive here, this one.
Please take your time.
Yeah. Okay. So let me share my screen. I just want to show an example. This is a very simple artificial neural network lines of code, which I use to teach my students. So in this case, you can see here, first of all, I was trying to write an ANN code. So here I just import the libraries, right? I import the libraries that I needed. I import NumPy because I want to work with array numbers. I import pandas. I import TensorFlow, which I'm going to explain tomorrow. I import TensorFlow and call it TF. Now, in order to process my data, the first thing I did was to import my data set. And to import my data set, I have to establish the folder directory, the directory where I saved my folder. So two ways here. Either you can come here, for example, you can mount your folder inside your work. In this, for example, here I can mount. You see I have mounted some folders here. For example, I have California Housing Test CSV, Train CSV, MNIST Test CSV. These are sample data I have mounted here. So if you already have your data and you mount it inside your Colab, if you come here, you can say copy part. So when you copy the part, then the line of this code, you can replace it and place it by saying copy part. So in that case, your Colab will go to the part where the data set was saved and then bring it into your Colab environment. Then you can continue to work in your Colab environment. So the answer is yes.
Yes.
Okay, let me check. It's like somebody type a question. So give one example of simulator and emulator. Okay, so Professor already answered that question. OpenDSS is an example of what? Can somebody answer that question? Can somebody type that? OpenDSS is an example of what? Or let me just share my slide again. Professor already answered that question in his presentation. So Mininet is an example of emulator. OpenDSS is an example of simulator. Why? The question should be why. Why is Mininet an example of emulator? Why is OpenDSS an example of a simulator? To answer that question, we need to ask ourselves, what is a simulator? A simulator is trying to capture the scenario. You are trying to capture a scenario and you are trying to run a scenario to look like how the real scenario is. But in emulator, you are trying to build that scenario. That's why if you check in this diagram, you could see, take note of something, you could see that in this simulator, we have some bus numbers 611, 684, 671, 680, 652. If you come here, if you come to this emulator, you will see that the hardware, the computer hardware, we are representing the same one-to-one. So if you have 652 bus, 652 node in this bus, you have the H652. So you have the DER that represent this 652. The 684, you have the DER that represent this 684. The 611, you have the DER that represent this 6. So this guy in the middle is behaving like an emulator, while this guy here is being used to simulate the grid. Why this guy is being used to emulate the grid, to imitate the grid. So if you are imitating, that means you are using an emulator. But if you are experimenting something that represents the alternative of something, you are simulating. And any device or any tool you use to do that is a simulator. So in this case, the OpenDSS is a simulator, while Mininet is an emulator. So these are very typical example of what is an emulator and what is a okay. Yeah, thank you, Akash, for making it easy for me to explain. But you also have to be careful. It's not the only when it is software that makes it a simulator. You also have to be careful. For the purpose of this class, I will agree with you that because it's only software, it is a simulator. But sometimes it's not only that, because you can also have something that demonstrates something that is not a software. But this is a very beautiful explanation. Thank you, Akash. Then somebody says, which among Mininet, NS3, and EtherCAP is better for network simulation and analysis, and why? Okay, first and foremost, I want to put put a caveat. I am always afraid of promoting private companies' products. These are product of companies, so I don't want to say Mininet is better than NS3 or NS3 is better than Etacap, because the companies do the adverts by themselves. However, I just want to show you what, just like what I've explained today, the immediate project you are doing will determine the closest one you want to use, or the operating systems and the hardware resources you have will also affect which one you are going to choose. Take, for example, I have never used Etacap, not because I don't know if it is good or if it is bad, but in all my 20 years of work, I have never needed it. So I can't even tell you if it is good or bad because I've never used it before. But I have only used Mininet, I have used NS3, I have used NetworkX, I have used MATLAB in my many years of working. And I can tell you, none of them is better than each other. I only use each one whenever it is the best for a particular problem I am trying to do at that particular point in time. That's why in our research papers, in the experimentation, we have to declare which one did you use, not because this is better than this, in my own judgment. I've never did any research trying to know which one is better. Rather, I have always used each one that suits me at the point in time when I'm trying to do my research work. Then somebody says, how do their feature compare in terms of usability, scalability, and real-world applicability? Okay, so if that is the angle you are coming from, I will tell you that if you are trying to work on this grid network simulation and analysis, then Mininet will be better than NS3. I don't want to talk about Etacap. I've never used it before, so I don't want to condemn. I don't want to say about it. I will only say, based on your question on usability, scalability, and real-world applicability, then I will recommend Mininet instead of NS3. But if you are here and you are a computer network person, you are not into grid or power grid research modeling. If you are doing computer networking modeling, then NS3 will be better than Mininet. So NS3 will be better than Mininet if you are doing computer networking research. But if you are going to do emulator research that involve grid, OpenDSS, and the rest of them, then I will encourage you to choose Mininet instead of choosing NS3. Then if you are just doing generic networking demonstration, maybe you have a demonstration to do, you want to present something to stakeholders and you want to quickly draw your network, just use NetworkX to draw. In NetworkX, there is no real world applicability in NetworkX. It's just a graphical simulator. It's just a graphical networking, just for you to visualize and draw. But based on grid simulation and research, Mininet is better than NS3. Any other question? I don't think so. How much time? Simulate the model in example 2. Does the simulation means? Okay, no, this was a question to professor, not me. Okay, the page you are trying to do not want to visit the page, you can return to the previous page. Okay, what are the challenges in synchronizing data? Okay, the last person says, what are the challenges in synchronizing data, Mininet and OpenDSS? Okay, so let me we have different level of experience. My experience is very limited, but I will just tell you one of the challenge I had. Number one challenge is platform. If you are using a computer that is having admin control, that is, you are using a platform that is associated with an organization where you are working, you have to check out if that organization does not allow you to install certain things in your system. In that case, you have to either use your personal system or you have to use VPN to ensure that it runs. That's number one. Number two, if you want to do a more rigorous work, you may need to leave Windows and move to Linux environment. It's another challenge. It's another challenge. But if your research is very small, you're not doing something so complicated, then I think your collab will be fine. Your collab will be fine. Then the synchronizing data between Mininet and OpenDSS. Another challenge also has to do with the unrealistic unrealistic grid parameters. So it means that for you to even be able to do any form of simulation, I will encourage that you need to have a good knowledge of smart grid and power grid interdependencies before you can even do the research work. But the major challenge you are going to have, which I already have, is when you are, it's more difficult outside Linux environment than in Linux environment, in Windows environment. But if you are comfortable, if you have been using Colab for a long time, or you've been using Windows for a long time, you may be able to navigate your way. Sohan Barrow, say thanks for clearing the doubt. Okay, thank you. Thank you also.
Basu, hello.
Yes, sir.
Yeah.
I think there is no more questions, I guess.
Yes, sir.
So, thank you, Dr. Kasmas, for your insightful course or lecture on the this integrating Google Colab with the different simulator emulator. So it is really